June 7, 1944, dawn breaks cold over the cliffs of Calvados. Oberleutnant Klaus Hoffmann stands in a concrete observation bunker, binoculars pressed against his face. His breath fogs the lenses. Below him, the beaches are still smoking from yesterday's chaos. Bodies, wreckage, the invasion they all knew would come. But something else is happening now. Out beyond the surf, in the gray morning light, shapes are appearing, massive, geometric, rising from the water like the bones of some ancient sea creature dragged up from the deep. He adjusts the focus, metal walls, platforms, cranes swinging into position. "Herr Oberleutnant," his radio man whispers, "what are they building?" Hoffmann doesn't answer. He's read the intelligence briefs. High Command dismissed it as Allied fantasy, propaganda meant to confuse. No army, they said, could construct a functioning harbor in open water. Not in days, not under fire, but the shapes keep rising. By noon, trucks will roll down floating roads. By evening, supply ships will dock where there was only ocean yesterday. Hoffmann lowers the binoculars. His hand is shaking. The war, he realizes, has just changed. The problem was simple. The solution was not. By 1942, every Allied planner knew that defeating Nazi Germany required landing an army on the coast of occupied France. Not a raid, not a commando strike. A full invasion force capable of sustaining itself long enough to break through Hitler's Atlantic Wall and drive toward the heart of the Reich. But Europe's coastline was a fortress. From Norway to the Spanish border, German engineers had spent 3 years pouring concrete and stringing wire. Rommel himself walked the beaches of Normandy that spring, ordering more mines, more bunkers, more obstacles designed to turn the surf red before a single soldier reached dry sand. The Allies needed ports, massive deepwater harbors capable of unloading thousands of tons of supplies every day, fuel for tanks, ammunition for artillery, food for men who would be fighting hundreds of miles inland within weeks. The nearest major port was Cherbourg. The Germans knew it. They fortified it with divisions of infantry, coastal artillery, and demolition charges wired into every dock and crane. Intelligence estimates predicted it would take months to capture. Even then, the harbor would be a smoking ruin. Dieppe had taught them that lesson in blood. August 19, 1942. A mixed force of Canadian and British commandos stormed the French port town in what was sold as a raid, but felt like a rehearsal for something larger. The planners wanted to test German defenses. They wanted to see if a port could be taken by surprise and held long enough to matter. It couldn't. German machine guns shredded the landing craft before they touched sand. Tanks bogged down on the shingle beach. Engineers trying to blow obstacles were cut down in the open. Of the 5,000 men who went ashore, more than half were killed, wounded, or captured within 9 hours. The operation was a disaster, but it clarified one brutal truth. Any attempt to seize a fortified port would cost more lives than the Allies could afford to lose. Winston Churchill understood this. He had watched the Dieppe casualty lists come in and knew the math didn't work. Invading France without a harbor was suicide. Invading with one meant bleeding the army white before the real fighting even started. So in the spring of 1942, during a meeting with his military chiefs, Churchill scribbled a note that would change the course of the war. It was brief, almost offhand, but it carried the weight of desperation wrapped in audacity. "Piers for use on beaches," he wrote. "They must float up and down with the tide. Don't argue the difficulties. The difficulties will argue for themselves." What he was asking for didn't exist. No nation had ever built a portable harbor. The engineering challenges alone seemed insurmountable. Tides along the Norman coast rose and fell 20 feet. Storms in the English Channel could generate waves tall enough to snap steel, and whatever structure they designed would have to be constructed in secret, towed across open water, and assembled under fire. But Churchill wasn't asking. He was demanding the impossible because the alternative was unthinkable. British engineers began sketching designs that summer. Concrete caissons the size of apartment buildings, floating roadways that could flex with the waves. Breakwaters assembled from sunken ships and interlocking steel units. The project had no name yet, no clear blueprint, just the vague outline of an idea that seemed to violate every principle of marine construction. Across the Atlantic, American military planners were wrestling with the same problem. Eisenhower had been named Supreme Commander of Allied forces in Europe. His job was to plan the invasion. His nightmare was logistics. An army fighting inland needed 500 tons of supplies per division per day. Without a functioning port, that army would starve in a week. The Americans brought industrial scale. The British brought design innovation. Together, they began work on something that intelligence analysts would later call the most ambitious engineering feat of the war. 2 artificial harbors, each one capable of handling more cargo than the port of Dover, each one designed to be operational within days of the invasion. They called it Operation Mulberry, and for 2 years it remained one of the most closely guarded secrets of the war. The construction began in the winter of 1943. Across southern England, 45,000 workers reported to sites that didn't officially exist. Shipyards, dry docks, quiet stretches of riverbank where concrete forms rose like monuments to something no one could discuss. Security was absolute. Workers were told they were building components for coastal defenses, submarine pens, floating fuel depots, anything but the truth. Compartmentalization became doctrine. A welder working on a steel roadway section had no idea it would connect to a floating pier. A crane operator lifting a concrete caisson into the water didn't know it would become part of a harbor wall. The scale was staggering. Each Mulberry harbor required over 150 separate structures. Phoenix caissons, massive hollow concrete boxes weighing up to 6,000 tons each, formed the outer breakwaters, 60 of them in total. Each one had to be built, floated, and held in reserve until the invasion order came. Then there were the whale units, floating roadways made of steel spans resting on pontoons. These had to support the weight of fully loaded trucks driving from ships anchored offshore to the beaches. The engineering tolerances were brutal, too rigid and the waves would shatter them, too flexible and vehicles would slide off into the channel. Bombardon breakwaters added another layer of complexity. These were cruciform steel floats designed to absorb wave energy before it reached the inner harbor. Each one weighed 200 tons. They had to be positioned precisely, anchored in water that could shift from calm to violent within hours. And then there were the block ships, obsolete freighters and warships that would be deliberately sunk to form an initial breakwater. 70 ships in total, crewed just long enough to position them off the Norman coast before seacocks were opened and they settled onto the seabed. The logistics alone made D-Day look simple. Every component had to be pre-positioned along the southern coast of England, hidden in estuaries, camouflaged in harbors, ready to be towed across the channel the moment the beaches were secured. Timing was everything. The Phoenix caissons couldn't be moved until the invasion began. They were too large to hide and too obviously military in purpose. German reconnaissance flights over the English coast were constant. A single photograph showing massive concrete structures being towed toward France would compromise the entire operation. So they waited, month after month. Engineers ran calculations, tested prototypes in controlled conditions, worried about the 1,000 things that could go wrong. Weather was the great unknown. The English Channel in June could be deceptively calm or lethally rough. Towing a 6,000-ton concrete box across open water in anything more than moderate seas was a gamble. Lose too many caissons in the harbor wouldn't function. The invasion would succeed only to collapse from lack of supply. Allied intelligence worked overtime to keep the project hidden. Disinformation campaigns hinted at plans to seize existing ports. Fake radio traffic suggested supply lines running through Calais. German agents in England already turned. Eden, controlled by British counterintelligence, sent reports describing coastal fortifications and invasion barges but never mentioned harbors. The deception held. German high command knew the Allies were planning something large. Rommel reinforced the beaches. Hitler obsessed over where the blow would fall. But the idea of a portable harbor never made it past the initial intelligence filters. It was too absurd, too technically impossible. Even within the German military, engineers who heard rumors of such a project dismissed them as wishful thinking. Building a harbor took years. Concrete needed time to cure. Structures needed foundations driven deep into bedrock. The notion that an enemy could simply float a functional port across the channel and anchor it in place seemed like the fantasy of men who didn't understand how the sea worked. That underestimation would prove fatal, because on the morning of June 6, 1944, while German defenders were still reeling from the largest amphibious assault in history, the first components of Mulberry were already moving. Tugs strained against tow lines, Phoenix caissons wallowed in the swell. Engineers aboard command ships checked charts and tide tables calculating the exact moment when the artificial harbors would begin to take shape in enemy waters. The invasion had begun, but the real engineering miracle was only just starting. The Phoenix caissons were monuments built to drown. Each one stood as tall as a 5-story building. Hollow reinforced concrete shells with walls 3 feet thick. They weighed as much as a light cruiser, and they were designed for a single purpose: to be flooded, to sink, to settle onto the seabed and form a breakwater capable of stopping North Atlantic swells. British engineers had tested smaller versions in Scottish locks. The concept was sound: pump air into the interior chambers and the caisson would float. Open the valves and it would sink in a controlled descent. Once on the bottom, the sheer mass would hold it in place. Link enough of them together and you had an artificial reef capable of creating calm water where none existed. But theory and practice were different things. The seabed off Normandy was soft mud and sand, unpredictable. A caisson settling unevenly could crack, flood asymmetrically, tip over and block the exact channel it was meant to protect. Precision mattered, and precision in open water, under fire, with tides running and winds shifting, was almost impossible. The whale roadways were even more delicate. Steel bridges floating on pontoons. Each section was 80 feet long and had to connect seamlessly to the next. The roadway needed to rise and fall with the tide while staying level enough for trucks to cross. Engineers designed telescoping legs that rested on the seabed and allowed the spans to move vertically without breaking apart. It sounded elegant on paper. In practice, it meant every joint was a potential failure point. Saltwater corroded steel, waves twisted pontoons, and if a single section broke loose, the entire pier could unravel like a chain with a missing link. Then there was the human element. 45,000 workers had spent 2 years building components they didn't fully understand. Welders in Liverpool joined steel plates without knowing they were making roadway sections. Concrete pourers in Southampton filled forms without realizing they were creating harbor walls. Dock workers in Plymouth loaded equipment onto barges without understanding the final destination. The secrecy took a psychological toll. Men worked 12-hour shifts in winter rain. They watched structures gratzars. Owen wondered what they were for. Rumors spread. Some thought they were building fortifications for the British coast. Others believed it was part of a deception plan. A few guessed the truth but kept silent. The exhaustion was cumulative. By the spring of 1944, accidents increased. A crane operator in Tilbury fell asleep at the controls and dropped a steel beam into the Thames. A welder in Chatham made a faulty joint that had to be cut out and redone. Fatigue led to mistakes. Mistakes led to delays. And delays meant the entire operation was perpetually on the edge of missing its launch window. Command staff pushed harder. Shift rotations extended. Safety inspections were expedited. The pressure to finish on time overrode almost every other consideration, because the date had been set. Eisenhower had given the order, and if the Mulberry harbors weren't ready when the invasion launched, thousands of soldiers would pay the price. Meanwhile, German intelligence was failing in ways that seemed almost willful. Luftwaffe reconnaissance flights over southern England photographed the Thames estuary and the Solent. They saw activity, ships, construction, but they didn't see the pattern. Abwehr agents in London sent reports describing increased military movement. They noted supply depots being established near the coast, but nothing in their intelligence suggested a harbor was being built. Nothing indicated the Allies had solved the fundamental problem of sustained logistics. Part of this was structural. German intelligence had been crippled by years of infighting and political purges. The Abwehr and the SD despised each other. Reports were filtered through ideological lenses. Anything that contradicted Hitler's assumptions was dismissed or buried. But part of it was also a failure of imagination. German engineers knew how harbors were built. They understood the constraints. Concrete had to cure. Pilings had to be driven. Docks had to be anchored to bedrock. The idea that an enemy could bypass all of this with prefabricated components seemed technically absurd. So when reports did surface, mentioning large concrete structures being moved toward the coast, they were categorized as defensive works, coastal fortifications, perhaps even decoys meant to draw attention away from the real invasion preparations. The Allies did nothing to correct this misunderstanding. Deception operations fed the narrative. Double agents confirmed that Britain was reinforcing its southern coast. Fake radio traffic discussed harbor defense plans. Aerial reconnaissance was allowed to photograph certain sites while others were camouflaged beyond recognition. The result was a blind spot, a gap in German strategic awareness that would not be noticed until it was far too late to matter. Weather controlled everything. The English Channel in June could shift from mirror calm to storm-lashed chaos within hours. Engineers had studied decades of meteorological data. They knew the patterns, they knew the risks, but knowing didn't mean controlling. The invasion had already been delayed once. Eisenhower had set June 5 as the target date. Then the forecast turned grim. Low-pressure systems rolling in from the Atlantic, high winds, heavy cloud cover that would blind the air support. He postponed 24 hours. The window was narrowing. On the evening of June 5th, meteorologists presented him with a brief gap. A slight improvement, not ideal, but survivable. Eisenhower made the call. The invasion would proceed on June 6th, and with it, the Mulberry components would have to move. The first wave was the block ships, 70 obsolete vessels that had been stripped of anything useful and filled with just enough crew to sail them across the channel. They left English ports in the early hours of June 6th, wallowing through moderate seas toward coordinates off the Norman coast. Their job was simple: position themselves in two arcs, one off Arromanches for the British sector, one off Vierville for the American sector. Then open the seacocks and settle to the bottom. Their hulls would form the initial breakwater, a crude barrier to take the edge off the waves while the Phoenix caissons were towed into position. Crews watched the invasion fleet pass them. Thousands of ships, landing craft by the hundreds, warships firing broadsides into the German coastal defenses. The blockship sailors felt strangely detached. They were part of history, but their role was to sink quietly and be forgotten. By noon on June 6th, the first blockships were going down. Captains gave the order, valves opened, water rushed into compartments. The ships listed, rolled, and settled onto the seabed with a groan of buckling metal. Some landed upright, others tilted at angles that would make them less effective as barriers. But they were down. The first phase was complete. Then came the Phoenix caissons. Tugs began the slow tow across the channel on June 7th. Each caisson moved at walking speed. 3 knots on a good day, less if the seas kicked up. The crossing took 16 hours under perfect conditions. Conditions were rarely perfect. Engineers aboard the tugs watched the caissons like nurses monitoring a critical patient. The concrete shells rode low in the water, buoyancy chambers keeping them barely afloat. Any breach, any crack, any unexpected wave, and thousands of tons of concrete could flood asymmetrically and capsize. German coastal artillery was still active. Shells screamed overhead, most aimed at landing craft and supply ships closer to shore, but a few fell near the caisson convoys. Waterspouts erupted. Shrapnel peppered the tugs. One caisson took a direct hit, the shell punching through a buoyancy chamber. It began to list. Engineers frantically pumped water from adjacent chambers to stabilize it. They kept it afloat just long enough to reach the designated position before intentionally sinking it. The impact drove it 6 feet into the mud. It would hold, barely. Positioning the caissons was an exercise in controlled chaos. Each one had to be placed with precision. Too far apart and gaps would let waves through. Too close and they might collide during the sinking process. Survey teams worked from small boats, taking soundings, checking depths, signaling corrections to the tug crews. When the position was right, the order came. Open the valves, the caisson would shudder as water rushed in. It would settle slowly, then faster as the weight increased. Engineers listened for the groan of concrete meeting seabed. If it came too fast, it meant the bottom was harder than expected. Too slow meant soft mud that might not support the weight. One by one, the caissons went down, 60 Phoenix units forming 2 massive arcs. By June 9th, the outer breakwaters were in place. The bombardment floats were towed in next, anchored in lines to absorb wave energy. And then the whale piers began extending from the beach toward the anchored caissons. From the German observation posts, it looked like witchcraft. Aft, structures appearing overnight, roads forming across open water, ships docking where there had been nothing but surf and sand. Rommel received the first reports and didn't believe them. He demanded photographs. Reconnaissance flights confirmed it. The Allies had built harbors, functioning harbors, in less than a week. He understood immediately what it meant. The invasion could not be starved. The beachhead could not be contained. Every hour, more supplies flowed ashore. More tanks, more ammunition, more men. The equations that governed modern warfare had just shifted against him, and there was nothing his engineers could do to respond. The harbors were already operational, already changing the calculus of the entire campaign. June 9, 1944, the harbors are breathing. Mulberry. A sits off Omaha Beach in the American sector. Mulberry B lies off Arromanches in the British zone. Both are skeletal but functional. Phoenix caissons form the outer walls. Bombardment floats rise and fall with the swells. Whale piers stretch from the sand to deep water, their steel spans resting on pontoons that flex with the tide. The first Liberty ships are already docking. Cranes swing. Trucks roll down the floating roadways. Tires humming on metal grating, soldiers on the beach stop and stare. They've been ashore for 3 days. They've fought through bunkers and machine gun nests and minefields, and now there's a port where there wasn't one before. British engineers move among the structures with clipboards and wrenches, tightening bolts, checking welds, monitoring the stress points where steel meets concrete. Everything is holding. Barely, but holding. The numbers are starting to add up. By June 10th, Mulberry B has unloaded 2,000 tons of supplies. By June 12th, it's 4,000 tons per day. Fuel trucks form lines a mile long, waiting to fill their tanks from floating pipelines. Ammunition crates stacked 10 feet high on the piers, medical supplies, rations, spare parts for tanks already grinding their way inland. Eisenhower visits Mulberry B on June 12th. He walks the whale pier with Admiral Ramsey, the naval commander who oversaw the logistics. The roadway sways beneath their feet, gentle, rhythmic. Ramsey points to the Phoenix caissons in the distance. Each one of those is heavier than a destroyer, he says. We sank them in 40 feet of water and they haven't shifted an inch. Eisenhower watches a column of Sherman tanks rolling past. The vibration travels through the pier. He feels it in his boots. How long can it last, he asks. Ramsey doesn't answer immediately. He's looking at the sky. The wind is picking up. Clouds are moving in from the west. Long enough, he says. But the weather is changing. Meteorologists in London are tracking a low-pressure system forming over the Atlantic. It's unusually deep for mid-June, the kind of storm that should arrive in autumn, not summer. Forecasts predict it will reach the channel by June 18th. Field commanders receive the warnings. Vessels at anchor are ordered to secure additional lines. Engineers inspect the whale piers looking for weak points. The bombardment floats are checked for damage. Everything that can be reinforced is reinforced. On June 18th, the wind begins to build. By evening, whitecaps are forming beyond the breakwaters. The Phoenix caissons, designed to stop normal swells, are facing something else. Waves 6 feet high, then 8, then 10. The bombardment floats absorb the first impacts. They're designed for this. Cruciform steel structures that ride the waves and dissipate energy, but the storm keeps intensifying. By midnight, waves are breaking over the caissons themselves. Spray shoots 30 feet into the air. The inner harbor, which had been calm enough to dock ships, starts to churn. Whale piers begin to twist. The pontoons lift and drop with each wave. Steel spans flex, bolts groan. Engineers watch the tide gauges and realize the storm is pushing water into the harbor faster than it can drain out. The piers are designed to rise and fall with the tide, but this isn't a tide. This is surge. One of the whale sections at Mulberry A snaps. The pontoon breaks free from its mooring and the steel span drops into the water. Trucks that had been crossing moments before are stranded. The roadway is cut. Repair crews scramble, but the wind is blowing 40 miles per hour. Waves are washing over the piers. It's too dangerous to work. They retreat to the beach and watch the storm tear into 2 years of planning. By the morning of June 19th, the gale is at full force. Sustained winds of 50 miles per hour. Gusts to 70. Waves 15 feet high crashing into the breakwaters. Ships at anchor are dragging. Captains fire up engines and try to hold position. Some cut their lines and head for open water. It's safer to ride out the storm in the channel than to be smashed against the artificial harbor. The Phoenix caissons are holding. Their mass keeps them anchored, but the bombardment floats are failing. Anchors tear loose. The steel cruciform structures collide with each other, smashing and bending. One breaks completely and is driven into the whale pier at Mulberry A. The impact shatters 3 pontoons. A section of roadway collapses. More failures cascade. Without the bombardments, the full force of the waves hits the inner harbor. Whale piers designed to handle 2-foot swells are taking 8-foot breakers. Pontoons crack. Steel spans buckle. The entire structure begins to come apart. At Mulberry A, chaos becomes catastrophe. By June 20th, half the whale piers are destroyed. Phoenix caissons, battered by debris, begin to crack. One floods and tips over, creating a gap in the breakwater that lets waves pour through unimpeded. The harbor that had been unloading 4,000 tons a day is now a twisted wreck. Mulberry B in the British sector is suffering but surviving. The seabed at Arromanches is slightly harder. The caissons settled more evenly. And the British engineers, perhaps luckier or perhaps more cautious, position the bombardments closer together. When they fail, the damage is contained. But even Mulberry B is crippled. Piers are damaged. Pontoons are lost. Unloading operations cease completely. For 3 days, the entire invasion supply line grinds to a halt. Eisenhower's nightmare is coming true. an army fighting inland with no way to feed it. June 22, 1944, the storm breaks. The wind drops to 20 miles per hour, then 15. By evening, the channel is almost calm. The sky clears. Sunlight cuts through the clouds and illuminates the wreckage. Mulberry A is gone, not damaged, gone. 70% of the whale piers are destroyed. The bombardons are scattered across the seabed. Phoenix caissons that took months to build are cracked and useless. American engineers survey the remains and write it off. Mulberry A will never function again. But Mulberry B is still breathing. Damaged, yes. Crippled, yes. But repairable. British engineers wade into the water and begin salvage operations before the waves have fully subsided. Pontoons are dragged back into position. Steel spans are welded. Cranes that had been knocked over are winched upright. And in a decision that will define the rest of the Normandy campaign, Eisenhower orders all resources focused on saving Mulberry B. Components from the American harbor are towed across to Arromanches. Phoenix caissons that survived at Omaha are refloated and repositioned in the British sector. Whale sections are cannibalized. Everything salvageable is moved. The repair work is relentless. Engineers work around the clock. Divers go down in cold water to secure anchor chains. Welders repair cracks by the light of arc lamps. Ships waiting to unload sit at anchor. Crews watching the harbor slowly come back to life. By June 25th, the first pier is operational again. By June 29th, Mulberry B is handling 7,000 tons of supplies per day, more than it did before the storm, because now it has components from 2 harbors instead of 1. The Germans are watching this. Rommel receives reconnaissance reports showing the British harbor not only surviving but expanding. He understands the implications better than anyone in the German high command. The storm should have been his ally. It should have crippled the invasion logistics, forced the Allies to rely on captured ports, bought him time to reinforce and counterattack. Instead, the Allies adapted. They rebuilt. They kept the supplies flowing. On June 28th, Rommel writes to his wife. The letter is brief, uncharacteristically bleak. He mentions the harbor at Arromanches, calls it a technical marvel, admits that Germany has nothing comparable, nothing that could respond to such industrial flexibility. The enemy's ingenuity is beyond anything we anticipated, he writes. They bring their ports with them. He doesn't say what he's thinking, that the war in the West is already lost, that the Atlantic Wall, which he spent months reinforcing, has been bypassed not by brilliance in battle but by brilliance in engineering. The soldiers fought hard, but the engineers won. By July 1944, Mulberry B is handling more cargo than any port in Europe except Liverpool. 10,000 tons per day. Vehicles roll ashore every 3 minutes. Fuel pipelines stretching from the harbor to the front lines deliver 1 million gallons a week. The British Second Army and the American forces farther west are pushing inland, and they are doing it with supply lines that never falter. The breakout from Normandy, which historians will call the beginning of the end for Nazi Germany, is possible because of a harbor that didn't exist 3 weeks earlier. Because engineers solved a problem that every military planner in history said was unsolvable. German commanders in Normandy are fighting a defensive campaign with no strategic depth. Every time they establish a line, Allied armor punches through it. Every time they try to counterattack, Allied artillery buries them. And behind it all, feeding the advance, is the artificial harbor at Arromanches, the harbor that was supposed to be propaganda, the harbor that couldn't be built. By the time Mulberry B is finally decommissioned in November 1944, it will have unloaded 2.5 million tons of cargo. That's more than half of all supplies landed in France during the critical first 5 months of the invasion. Fuel, ammunition, vehicles, the tools of war flowing across floating piers in quantities that would have seemed impossible just a year earlier. And the Phoenix caissons, those massive concrete shells that sank into the mud off Arromanches, are still there, still visible at low tide. Monuments to the day engineering changed the course of history. The numbers tell the story better than any battle report. Between June 9th and November 19th, 1944, Mulberry B handled 2.5 million men. That's not a misprint. 2.5 million soldiers processed through a harbor that didn't exist until the invasion started. They came ashore, moved through staging areas on the floating piers, and headed inland to join units already fighting. 500,000 vehicles, tanks, trucks, jeeps, ambulances, self-propelled guns, all of them driven down whale roadways that swayed with the tide but never collapsed. Engineers had calculated load limits down to the pound. A single roadway section could support a fully loaded Sherman tank plus 2 supply trucks side by side. The flow never stopped. Convoys moved 24 hours a day, 4 million tons of supplies, food, medicine, ammunition, fuel, spare parts, tents, radios, everything an army needed to sustain operations hundreds of miles from the coast, and it all came through a harbor assembled in enemy waters under fire. By August 1944, Allied forces had broken out of Normandy and were racing across France. Patton's Third Army was covering 40 miles a day. The German front was collapsing, and the supply lines, which should have been the limiting factor, were keeping pace. Mulberry B was handling more tonnage than the port of Cherbourg, which had finally been captured but was so heavily damaged it wouldn't be fully operational until September. The strategic impact was incalculable. Without the artificial harbors, the invasion would have stalled on the beaches. History is full of amphibious assaults that succeeded tactically but failed strategically because the attackers couldn't sustain logistics. Gallipoli in World War I, Anzio in 1943. Both were beachheads that won the landing but lost the campaign because supplies couldn't flow fast enough. Normandy was different. The beaches were secured on June 6th, the harbors were operational by June 9th, and by the time the German army realized what was happening, it was too late to stop it. Field Marshal von Rundstedt, overall commander of German forces in the West, received a briefing on the Mulberry harbors in late June. He listened in silence as his intelligence officer described the scale. The Phoenix caissons, the whale piers, the tonnage being unloaded every day. When the briefing ended, von Rundstedt asked a single question. Why were we not informed this was possible? The intelligence officer had no answer, because German intelligence had dismissed it, because the engineers said it couldn't be done, because the idea of a portable harbor seemed like a fever dream cooked up by men who didn't understand the sea. Von Rundstedt stood and walked to the map on the wall. He stared at the Normandy coast, at the blue pins marking Allied positions, at the red pins marking German forces that were being pushed back day by day. We've lost, he said, not loudly, almost to himself, not because their soldiers are better, because their engineers are. He was right. The Mulberry harbors didn't win the war by themselves, but they made victory possible. They turned a tactical success into a strategic one. They gave the Allies the one thing the Germans couldn't counter: time, space, the ability to build combat power faster than the enemy could respond. Rommel understood this too. By July, he was writing reports to Hitler that bordered on defeatism. He described the Allied supply capacity as overwhelming. He noted that German forces were outnumbered, outgunned, and outsupplied. He recommended withdrawing from Normandy before the entire army was encircled and destroyed. Hitler refused. He ordered Rommel to hold every inch of ground, to counterattack, to push the Allies back into the sea. It was fantasy, and Rommel knew it, because every day more tanks rolled off the Mulberry piers, more ammunition crates stacked on the beaches, more fuel trucks headed inland to keep the advance moving. On July 17th, Rommel's staff car was strafed by Allied fighters. He was badly wounded and evacuated to Germany. He never returned to Normandy. By October, implicated in the plot to assassinate Hitler, he would be forced to take poison. But before he left France, he wrote one final assessment of the campaign. It was clear-eyed and brutal. "The war in the West is lost," he wrote. "The enemy's logistical superiority cannot be overcome. We are fighting an industrial power that brings its factories to the battlefield." He was talking about the harbors, the floating piers, the concrete caissons that turned open water into a supply hub. He was talking about an idea that German intelligence said was impossible, but that British and American engineers made real. The psychological impact on German forces was as devastating as the material one. Soldiers in the bunkers along the Norman coast had spent years preparing for an invasion. They trained, they dug in, they wired obstacles and sighted their guns. When the landings came, they fought hard. Casualties were brutal on both sides, but the Germans held positions. They made the Allies pay for every yard. And then they saw the harbors, structures rising from the sea, ships unloading in open water, supply convoys moving down floating roads as if the ocean itself had been tamed. It broke something in the German defensive psychology, because it meant the invasion wasn't a raid. It wasn't even a beachhead that might be contained. It was permanent. Prisoners of war interrogated in late June spoke about the harbors with something close to awe. They described watching the Phoenix caissons being positioned, seeing the whale piers XT, and day by day, realizing that the Allies weren't dependent on capturing Cherbourg or any other port. They had brought their own. One German NCO captured near Carentan told his interrogators that morale collapsed the moment the men understood what they were seeing. "We knew we could fight the soldiers," he said. "But how do you fight that?" He was pointing toward the coast, toward Mulberry B, toward the evidence that the enemy had solved a problem Germany couldn't even conceptualize. It wasn't just the frontline troops. German logistics officers were equally stunned. They knew the math. They understood supply requirements. A single panzer division needed 300 tons of supplies per day just to sustain operations. The Allies were landing divisions, plural, and keeping them fed and fueled without a major port. German staff officers ran their own calculations and came up with numbers that didn't make sense, until they accounted for the artificial harbors. Then the numbers worked, and the strategic picture became clear. The Allies could build combat power faster than Germany could respond, and there was no way to cut the supply line because the supply line was a mobile, self-contained harbor that could be repaired faster than it could be destroyed. Luftwaffe pilots tried. Raids on the Mulberry harbors began in mid-June. Bombers came in low, targeting the whale piers and the Phoenix caissons. A few hits were scored, minor damage. One whale section was destroyed by a bomb. But the raids cost aircraft Germany couldn't afford to lose, and the damage was repaired within days. By July, the raids stopped. The Luftwaffe didn't have the strength to sustain them, and even when they succeeded, it didn't matter. The tonnage kept flowing. U-boats made attempts as well. Submarines prowling the channel tried to torpedo the tugs that were still ferrying supplies and equipment to the harbors. A few cargo vessels were sunk, but the convoys were heavily escorted. Destroyers and corvettes patrolled constantly. The U-boats took losses they couldn't replace. The reality was simple. The Mulberry harbors had changed the nature of the campaign. They made the Normandy invasion sustainable in a way that no previous amphibious operation had been, and once that sustainability was established, the outcome was inevitable. By September 1944, the Allies had liberated Paris. By October, they were on the German border, and the logistics that made it all possible traced back to those floating piers off the Norman coast, to the engineers who built them, to the planners who believed in them, to the workers who spent 2 years constructing components they didn't fully understand. The British kept Mulberry B operational until November 1944. By then, the port of Antwerp had been captured and cleared. Deepwater harbors were available again. The artificial harbor, which had been a desperate improvisation born of necessity, was no longer needed. The Phoenix caissons were left in place, too massive to move, too embedded in the seabed to salvage. They sit there still, visible at low tide off the coast of Arromanches. Concrete and rust, monuments to the day human ingenuity outpaced human conflict. French locals call them the remains of the artificial port. Tourists photograph them, historians write about them, but the men who built them, who towed them across the channel, who sank them into the mud and watched them hold against storms and shells, most of them never spoke about it. They went home after the war, went back to ordinary jobs, and the world moved on. But in the summer of 1944, for 5 months, those caissons and piers and floating roadways did something no one thought possible. They turned the English Channel into a highway. They made an ocean into an ally. And they proved that wars are not won only by the men who fight them, but by the ones who solve the impossible problems no one else believes can be solved. Wars are remembered for battles, for leaders, for the moments when history pivots on the edge of a decision. But beneath the famous names and the dramatic turning points, there are always engineers, always the ones who solve the problems no one else sees coming. The Mulberry harbors were never supposed to be possible. Every principle of marine construction said they couldn't work. Every historical precedent said that harbors took years to build, not days, that they required bedrock and pilings and concrete cured over months, that you couldn't just float a port across open water and expect it to function under combat conditions. But the engineers didn't care what history said. They cared about the problem in front of them. An army needed supplies. Ports were fortified, so they built ports that moved. It wasn't one innovation, it was 100. Phoenix caissons designed to flood in a controlled descent, whale piers that could flex with the tide without breaking, bombardment floats that absorbed wave energy, block ships sunk in precise patterns. Every piece had to work, every piece had to be tested, refined, and mass-produced in secret. And when the storm came in June 1944, when the gale that should have destroyed everything battered the harbors for 3 straight days, the engineers didn't give up. They rebuilt, they adapted, they salvaged what they could and kept the supplies flowing. That's the lesson. Not that engineering wins wars, but that imagination does. The willingness to ask what if. The refusal to accept that something is impossible just because it's never been done before. The Phoenix caissons are still there, rusting in the surf off Arromanches. Most people who see them don't know what they are. Don't understand that they were once part of the largest engineering project of the war, that they made D-Day more than a successful landing. They made it a sustainable campaign. And somewhere in that tidal zone where steel and concrete meet the sea, there's a reminder that the impossible is just the difficult waiting for someone stubborn enough to solve it. That wars are fought by soldiers but won by the ones who make sure those soldiers never run out of bullets, or fuel, or hope. The Mulberry Harbors weren't propaganda. They were proof. Proof that human beings, when pressed, can accomplish things that defy belief, and that sometimes the most important victories are the ones no one sees happening